Good afternoon, everyone, from a very rainy and wet Ohio. My name is Lee Chiddention. I'm the HVAC market manager at Kinetics. So I head up the HVAC department that deals with vibration isolation, seismic restraint for the US and Canada. So we've got about a 20-minute webinar for you today that's about basic selection of isolation for vibration isolation. So we're going to just kind of rip through this and give you a little taste of vibration isolation and some basics. So without further ado, I'll get started. Basically, vibration is the unwanted motion that is transmitted to the building structure and the occupants, generally from rotating HVAC equipment. So as human beings, we're actually feeling this vibration from the mechanical equipment, and then our brains are equating that vibration and telling us there's a noise, a buzz. And also the main overlooked part of vibration isolation isn't just the noise it makes, is the fact that modern commercial buildings are made up of structural columns that are steel. And that vibration can get into the steel structure of the building and actually cause like a tuning fork effect. And you can actually see degradation and damage to the building structure over time when it comes to this vibration getting down into the building. So how do we get rid of that isolation? Basically, we resiliently decouple the equipment from the building structure by the use of vibration isolators. So we'll put the equipment on something that's going to absorb the vibration to stop that vibration getting through to the structure itself. So the specification of vibration isolation isolation's performance is actually of the system's natural frequency, which depends on the driving frequency, the mass that's being isolated, and the stiffness of the isolators. Almost all vibration isolation specifications define the required isolation by the static deflection of the isolators themselves under dead load. So what that means is you are actually looking at, once the weight of the equipment is on the isolator itself, how much deflection are we going to have from the isolator? So it's not, an isolator standing by itself. How much squish is going to be applied to the isolator once the weight of the equipment is on the isolators? And a lot of people look at it like it's black magic, vibration isolation, how do you determine? And there is actual science behind it when we look at things like the natural frequency and the driving frequency. So why are there so many different types of isolators, and what isolators do I need to choose? Essentially, in the olden days, we had a situation where the engineers would do long hand-drawn out mathematical equations to figure out exactly how much deflection was going to be needed for the isolation that was going to go onto the equipment. Fortunately, today, we have cheat sheets that are available, especially the ones that a lot of people reference from the ASHRAE handbook. Here at Kinetics, we've provided a simple isolation selection guide that takes those very charts right out of the ASHRAE handbook and makes them easily available in a glossy document for you to kind of keep either on your desktop in PDF format, or you can reach out to your local rep and get some of these sent out. As you can see from the website, if you just go to the download literature section of the website, it's the very top one here, and you can put yourself a PDF version of this document right on your desktop. So what I mean by bringing the charts from the ASHRAE handbook into the actual document, here's an example of the chiller page. So at the top, we have a nice picture of a chiller. And then, of course, we have that goes right with chillers right from the ASHRAE handbook pulled onto that page. Now, to understand how to work the charts from the ASHRAE handbook, I'm using an example here for a cooling tower. So this particular cooling tower, if you look at the location of the equipment, if the cooling tower is sitting slab on grade, if it's in an equipment yard or in the basement or the ground level of the building, it's going to need a 1/4 inch deflection, squish under the weight of the equipment of the isolator, and then it says that we need an ASHRAE type of 1. We'll go into the ASHRAE types here in a moment. We go to the very far right of this scale. So in other words, as the floor span of the building widens, which typically happens the higher we go in the building. So the higher we go in the building, the wider the supporting beams are for the floor itself, and you get a wider floor span. What happens is that once you get a wider floor span, the floor itself actually starts deflecting between its supporting columns. So the deflection of that floor itself can actually adversely affect the deflection of our isolator. So it makes sense. The more deflection we have in the floor itself, the higher we go in a building, the more deflection we need out of our isolator. So in this example, you're all the way up to a 3.5 inch deflection ASHRAE type 4 isolator. So we know that we're going to need a 4-inch spring to get us where we need to be. So you go from one extreme of just needing some pad, an ASHRAE type 1, to all the way up to the very higher end of the scale and needing like a 4-inch deflection spring. So let's look at the ASHRAE types and just kind of give you a brief overview of what they are. An ASHRAE type 1 is your simplest form of vibration isolation. It's some kind of pad that the equipment's going to sit on. So you're relying on the gravity, the weight of the equipment sitting on the pad, and then this pad is going to deflect a certain amount, and that's going to eliminate the vibration. Kinetics does offer a fiberglass isolation pad. Of course, the advantages of fiberglass, it does not get affected by sunlight. UV can't break down the fiberglass over time. The very reason we park our campers and RVs and we cover the tires up so the sun doesn't dry rot the rubber. Same thing with neoprene. That's going to break down for UV. And then temperature can affect rubber and neoprene. In Calgary, for instance, in the middle of the wintertime, a neoprene rubber isolator is rock hard. It's like a hockey puck, and it's not going to deflect. So the isolation is going to travel right through the hockey puck, as it were, as fiberglass is not going to be affected by temperature. ASHRAE type 2, we're still using pad, either rubber or fiberglass material, 1/4 inch deflection, but now we've got a way to control that pad. In other words, there's a way to bolt it down. So here you have a plate through the rubber so you can put bolts on either side, and then you can attach the equipment, and that stops the equipment walking away around as it shakes, much like your washer might do if you've got an off-balance load. This equipment's being held in place now, but it's still only a 1/4 inch deflection ASHRAE type 2 now instead of type 1. So instead of just relying on the gravity, the weight of the equipment, we now have a way to attach it down. An ASHRAE type 3 introduces the spring, whether it's a floor mounted spring as shown here, or whether it's a suspended hanging spring hanger. So here you can see the all thread would go through and attach at the top of the spring, and then you would attach this to the another piece of all thread, and then the equipment would hang below the hanger. So this is a way for you to use a spring hanger to suspend the equipment, and then this is a way for you to set the equipment on top of a spring. And of course, there is no way to bolt this down, so this would be a non-seismic housed spring isolator. So ASHRAE type 3. Once we move up to the ASHRAE type 4 isolator, now we have a way to restrain the spring, whether it be for seismic events, whether it be for wind on a rooftop. You know, we've taken this open spring concept where nothing can hold the equipment in an event, and now we've introduced, for instance, here a top hat type setup where this is now a restraint. So once the weight of the equipment is sitting on this bolt, this spring is freely floating and nothing is touching this housing. But if an earthquake were to happen and shake around, this bolt's going to catch inside this snubber here and stop the equipment from moving around too much. So you can see there's different types of isolators that are restricted and restrained for seismic or wind. This one has a cavity in the middle, and your snubbing element sits right in the middle of the cavity, and that would again restrain the equipment from moving. An ASHRAE Type 5 is going to be a thrust restraint. A thrust restraint would be installed in a pair. Essentially, when you have a large fan in line with a piece of ductwork, that fan is going to want to pull itself away from the ductwork as it powers up. The thrust restraint is there to keep that fan from pulling itself away. ASHRAE Type 6, we have airbags. So what's interesting about airbags are they are 100% efficient at eliminating vibration. So a 4-inch deflection spring on a roof under a cooling tower is about 99.7% efficient at eliminating the vibration. And an airbag is 100% efficient. So it's 0.3% more efficient in eliminating the vibration. Most times you're going to want to go with springs though, because an airbag of course does need air. That air comes from an air compressor. That air compressor is noisy, it vibrates itself, so now we've got another element in the system that needs isolated. They're very expensive because they need a control panel to control as they're self-leveling. Now, where airbags are really well utilized are in a situation where seasonally you may have a different weight on the equipment. For instance, if you've got a multi-cell cooling tower where the intent is to drain certain cells of the cooling tower in the wintertime, of course, the center of gravity of that piece of equipment is going to change substantially once you drain one of those cells. So now with the airbag system, it would level itself using the software on board. So there are the ASHRAE types of isolators that you have to choose from. And then we have the ASHRAE base types. A base type A is basically there is no base, okay? The equipment sits right on top of the isolator itself. Here we see a nice big chiller sitting on top of the isolator. So that's a base type A, direct mount. Base type B, we now have a structural beam or frame that's actually supporting the length of the equipment, and then the isolators are brought in under that structural frame or beam. The point is this equipment here is a cooling tower and it cannot be point loaded. You can't just sit the isolators under the equipment. The equipment doesn't have the structural rigidity to be able to sit on top of the isolators themselves. You need a supporting beam to distribute that weight across the isolators. So that is a base type B. A base type C, many of you have probably seen before. This is a concrete inertia base, typically called a CIB. Essentially, we're adding an inertia mass to the bottom of the pump or fan so that when that equipment kicks on, it doesn't try to jump out of shape or move. The mass underneath it is going to keep it from moving around. We then put springs under that concrete inertia base to isolate into the structure itself. So that's a base type C. Base type D are your spring rails for air handling units. Basically, you would have your factory roof curb, which is a sheet metal rectangle that has an opening into the building. The air handler is going to sit on top of that rectangle. We want to make sure we put springs between that rectangle and the unit to stop any vibration getting through to the space. And we do offer some acoustical packages, and I'll touch on that in a second. A lot of the Kinetics products do offer a QR code, so the contractor can scan with their cell phone the QR code, and then they can watch a simple installation video on how to properly set up, install, and adjust the isolators. I think the biggest fail we see at the factory are misadjusted isolators. So as you can see from this video, they're going to adjust the snubbing element down so they can start moving the springs, and then you adjust by doing 3 turns on each isolator and then moving around in a circuit. Once all of the isolators are floating, in other words, the blocking pucks become loose, you know that the isolator is properly adjusted, and you can now go ahead and tighten up the snubbing element to the 1/4 inch allowed movement for snubbing per code and walk away from that, and it is a properly installed isolator. We also have the same thing available for our concrete inertia paces. So anyone on site who is unfamiliar with the product can scan their cell phone over the QR code, and it's going to launch the YouTube video right on their phone or tablet. This one's showing some predetermined threads there for the pump to mount to, and then you're going to fill the base with concrete, and then the same kind of concept with adjusting the isolators correctly. All of these videos are available on the Kinetics website, as well as the QR codes that come on the product. Here we have a very rudimentary design for an isolation rail for a curb. So instead of using a spring rail, which is very expensive and often gets VE'd out of a project, here we're using strips of the Kinetics fiberglass isolation pad, and we're simply gluing those strips right to the factory curb. So you would just use like a liquid nails or a construction adhesive to attach the isolation right to the factory curb. The advantage of this is you will be able to utilize the internal isolation on the air handling unit. So the air handling unit has a fan inside of it. That fan has springs under it. When you have a spring rail, you have to lock those internal springs out, because a spring on top of a spring makes the vibration worse. But when you've got a spring working in series with a piece of pad, that works really well. So this is a good way to kind of offer a really nice, cheap solution anytime someone's looking to get rid of the spring rail. As far as acoustical options for the roof curb, you'd be looking at our ESSR packages. We do offer silencers, noise blocking panels, all inside of the curb. The reason is that from an air handling unit is a giant sheet metal drum skin, and that giant sheet metal drum skin has a bunch of energy flowing through it. So it doesn't matter if you isolate the fans internally, you're going to get airborne noise and so on. So vibration from the fans, we eliminate those with a basic vibration isolation rail. And then ductwork turbulence and airborne noise from the fans and the compressors, we control those also with the spring rail. And then the ductborne noise from the supply and return air fans, we actually use aerodynamic acoustical silencers from Kinetics, and we mount those inside the curb. We can basically give you the NC levels you need in the space. And then the breakout noise from the bottom of the unit, the most overlooked issue with air handling units is the breakout noise. You've got a hole into the space. So we've got to do something with that noise that's coming out the bottom of that unit. In this case, we could put a noise blocking acoustical panels in the bottom of the roof curb. And those come in different levels. So it's like a picnic basket. For instance, you can go with our cheaper RT7 that gives you an SDC rating up to 37. If that 37 is not high enough, you can jump into like our noise block, which is our micro perf sheet metal acoustical noise blocking panels that we use in our barrier wall system. This can lay in the bottom of the curb as well. And based on the different thicknesses available, you can get all the way up to an SDC level of 52 with that one. So again, with the ESSR products, it's very much a design system based on the application and the noise requirements of the installation. We're almost done. Two more things I wanted to touch on real quick. One of the biggest buzzwords in the industry right now is delegated design. We see it in an awful lot of specs. Things like pipe stress analysis, riser designs, understanding the stresses on runs of pipe, how much movement you're going to get, how to control that movement. Kinetics can do all of that engineering. We do a lot of delegated design, so we love to scoop up that work and help you add value with the customer's design engineers. Things like riser design, pipe stress analysis, whether there's some funky frame they want to put or a walkway around the cooling tower that needs to be integrated right into the design of the system. So delegated design, something we do at Kinetics. And also, we do virtual stress testing. So, you know, for instance, fan manufacturers have come to Kinetics, and we've basically gone ahead and taken their equipment, and we put that equipment in like a 3D model, and then stress test the equipment itself, and then offer a seismic rating based on the stresses that we can do for virtual stress testing. This saves the manufacturer having to send that equipment off to have it put on a shaker table testing and tested for seismic forces. So that's the end of the webinar. It looks like there was a question that popped up in chat here. And let me see if I can pull that up. Looks like it went away. Oh, do you still need an inertia base with springs for a base frame pump with a VFD? It just depends on the frequency of the actual equipment. So what I will do is I will leave you with my email, and please feel free to email me any questions you have. I have a whole team of inside sales engineers, if it's too technical, that are available to answer any questions. So our 20 minutes are up. I appreciate everyone's time, and I really hope everyone's staying safe. Thank you, and have a great day.